Well, thank you everybody for joining us today for this Hydroterra webinar. It's a very important topic we're discussing today, which is about the Great Barrier Reef. It's great to see so many people attending. Today our presenter is Dr. John Runcie, who's CEO of a company called Aquation, and I will talk a bit more to his background shortly. Nice picture of the reef there to just focus us all on what this is all about. These are our two presenters. So I'm the Managing Director of Hydroterra, and we are strong believers in communicating both technology around environmental monitoring, but also around important issues such as the Great Barrier Reef and other environmental significant, situations. And I think the Great Barrier Reef is one of our most significant ones in Australia. And as I mentioned, Dr. John Runcie is our presenter. Before we get rolling, a few things. We love to get your questions and we will endeavour to answer them today. Please use the Q&A button at the top of your screen there to put your questions in. Don't use the chat, please. Use the Q&A, and that way it's a more organised response that we can get back to you. It's just a bit easier logistically. But we want lots of questions. We love the questions. So why does Hydroterra run these webinars? Well, we're a bit obsessed here about sharing knowledge. I think in the industry, it's becoming more and more important to share knowledge about best practice and also about the big issues. I think sometimes we get a bit lost in the detail, or we get lost in a lack of media reporting of big issues too. So we seem to be getting a pretty good following around these sorts of webinars. So I think we're filling a need there in terms of sharing knowledge. Part of our webinar series is also about education, and we do run education webinars which have a 101 in front of them, which is really more about 101 on monitoring training, so how to monitor things like groundwater and surface waters, and they're very popular as well. Finally, I guess we are trying to take a bit of a leadership position in issues where we feel that it's required, and I think in the environment that we're in at the moment, there's no shortage of needs, so we will continue to present on these things. So a bit about today's webinar. We've done the introduction. John's then going to talk about facts and figures relating to the Great Barrier Reef. What are the threats to the reef? Who's responsible, right, for the reef? There seems to be a lot of different people who at various times may or may not choose to step up and take responsibility for its management. The role of UNESCO, what's an international body doing telling us what we should be doing with the reef? That's a good question. What's the Australian government doing? And finally, the role of monitoring, and our presenter today has a very strong background in marine monitoring. So our theme is the Great Barrier Reef beyond saving? Well, the beauty of today's presenter is he's a little bit impartial. He's come more from a background of monitoring and assessing marine systems as distinct from just specialising in coral reef systems. And to be honest, as a scientist, an environmental scientist, I get mixed messages about the state of the reef, and I'm sure you do too. Some people say it's actually more healthy than it used to be and that sort of thing. So I think it's good to have someone a bit impartial to present to us today on this. Just a bit about our speaker, and then I'll pass over to John to start his presentation. So John's an expert in marine pollution and its monitoring. He's an honorary research associate with Sydney University. He's got a PhD in marine biology, specialising in nutrient impacts on marine organisms. He's worked extensively around the world. So initially he started off with his PhD here in Australia on the Hawkesbury River, but he's worked on the Barrier Reef. He's worked in Hawaii in both deep and shallow coral reef systems. He's worked in Antarctica looking at macroalgae and the impacts of light on those. He's worked in Israel, Corsica, at various research stations in Spain, in Europe, working as Australia's representative on what was known as the COST program. I'm not quite sure what COST stands for, but really that was focused on seagrass impacts from change in light across the depth gradient. In addition, he's worked on the impact of contaminants, right, on marine environments, particularly things like dispersants used on oil spills, but also contaminants such as heavy metals and pesticides. His true specialisation, I suppose, and I've got to know John through really monitoring, looking at various monitoring technologies for marine environments that Hydroterra could sort of represent, is photophysiology of marine phototrophs. So that's seagrasses, macro and microalgae, underwater light and its importance to photosynthesis, nutrients, and using bioindicators to detect long-term elevated levels, pollutant transport and transfer in the environment, pesticides and petrochemicals, ocean acidification, which is a big one in this discussion, and genes in seagrasses and how they respond to different light environments. So without further ado, sorry, I did forget one very important thing. So we would like to do an acknowledgement of country on behalf of myself and John. So I would like to acknowledge the Wurundjeri people, who are the traditional custodians of this land. I would also like to pay respect to the elders, both past and present, of the Kulin Nation, the Darkajong, and extend that respect to other Indigenous Australians present. So without further ado, John, I will hand over to you, and many thanks for participating today.
Great, thanks Richard, for that introduction. So I'd like to give you a little bit of background to the Great Barrier Reef. I'm sure a number of you are across most of this detail, but I'll go through it for those who would like a refresher, or who are not familiar with it. There are, as you can read here, there's more than 70 traditional owner groups. There's a lot of Indigenous people up in that part of the world. It's the largest coral reef on Earth, so you can see it from a satellite, and it covers a wide range of environments, from very shallow inshore environments, going up to the mangroves and seagrasses and marshes, and then going up to 2,000 metres depth offshore. So the coral reef that we know as the beautiful place where the lots of little fish and colourful corals are, is a small proportion of the whole environment, and that's an important point. So there's a lot of the Great Barrier Reef that we don't see, and it's not charismatic, if you like. So the Great Barrier Reef itself makes up about 10% of the world's coral reef ecosystems. There's a lot of species in the Great Barrier Reef which represent species found elsewhere. Coral comprises only 7% of the marine park. Yes, and it extends into the airspace above and the earth beneath. And here we've got the seagrasses are an important part of it, mangroves, sand, algal and sponge gardens, and then the communities between the reefs. So most of the reefs are actually on the islands, and there's all this lagoon space between those islands, which is part of the Great Barrier Reef, going down to 2,000 metres. The reef itself contributes quite a lot of funds to the Australian economy through all the businesses that operate through there, not only tourism, but also commercial fisheries, and also the ports and the shipping that goes in and out of the reef. and there's a very large diversity of plants and animals. So you can see it's a significant it is a significant place. You can see on the map there on the top right, that long red patch all over Queensland is basically the reef. So next slide, Richard. So there's a bunch of institutions involved, as you're probably aware, the Great Barrier Reef Marine Park Authority, who has overall oversight on the reef. The Australian Institute of Marine Science focuses not only on the Great Barrier Reef, but other parts of the country as well. But up in North Queensland, their offices up there and their labs are focusing on the Great Barrier Reef, and they have for many years. We've got JCU, James Cook University, very important player, and then the Australian government, federal people, Department of Agriculture, Water and Environment, and they're the ones who are involved with some of the discussions with UNESCO. So UNESCO is the United Nations group, and they deal with the World Heritage listed parts of the world, of which the Great Barrier Reef is one. Okay. And we've got the GBR Foundation. So here's a nice picture. And this is actually one of the stories that people like to say. You've got a pretty colourful reef on the left, and then it's gone all bleached and horrible on the right. And that does happen, and I've seen that up there. And you can see on the right, you can see quite dead patches of coral. Yeah, and it's pretty striking. However, it's not everywhere. These sorts of events, natural events occur to cause these things, but also there's other more subtle pressures on the reef which contribute to these sorts of coral bleaching events and death of corals. So a list of threats here are fishing and commercial activities such as ports. One of the things people do in ports is they have to maintain the port depth so the ships can get in and out, and that requires dredging. So dredging releases a lot of sediment. So a port in itself is not necessarily going to impact on the reef, but the activities around the port, including the dredging, do have a significant effect on not only corals around, but also seagrasses and potentially mangroves as well. One of the major threats that's been talked about in the news over the last, well, over 10 years is crown of thorns starfish. These starfish, they eat coral. And sometimes so many of these starfish are present on a coral reef or an atoll that most of the coral's been eaten. So it's always been a concern since people realised that crown of thorns created problems as to how the effect of crown of thorns would impact the reef. And there's large projects to manage those starfish. In terms of water quality, there's a number of elements which impact on the coral reef and the organisms around that area. So elevated nutrients will cause algal blooms, and these algae can often overtake some of the corals. What they actually do, the elevated nutrients will change the species composition within the reef waters. And that change in composition can lead to quite a lot of systemic changes in population structure. And that can lead to real problems. The sedimentation is a really obvious one, where you've got all that sediment coming out of the rivers, and essentially it blocks the light from most of the plants and animals that live there. Corals need light, even though they're an animal. They have algae within them, and those zooxanthellae require light. So when there's a lot of sedimentation, the corals get essentially smothered, and they're less able to survive. So sedimentation is a massive problem. Now, pesticides is another terrigenous contaminant, and in particular herbicides, if they can get into the reef itself, they can affect anything that is a plant. And so the zooxanthellae are also susceptible to some pesticides. Then you've got plastics, anti-fouling, tributyl tin, for example, personal care products. So you've got a range of different pollutants which will affect organisms in the reef. So these are the water quality aspects. But now we've got a list here of things which are less obviously anthropogenic. We've got cyclones, which cause massive damage. We've got marine heat waves, and elevated temperatures is what causes the zooxanthellae to leave the corals, leading to bleaching. And we've had a number of marine heat waves in the last 10 years. And then we've got ocean acidification, which is a consequence of elevated carbon dioxide in the atmosphere. And that leads to reduced rates of calcification in organisms in the sea. So that cyclones, marine heat waves, ocean acidification line is not something that we necessarily see as a human impact, but I think we should consider the effects that we might be having on those sorts of events. And then the bottom line here, bottom line in two ways, cumulative impacts. So if you elevated the nutrients and you did nothing else, you'd have a certain impact. But if you did that and increase the sedimentation and potentially increase the temperature, then you'll have a cumulative impact. And the evidence shows that the cumulative impacts are what is causing a real problem for the organisms in the reef. And so what we're looking at in terms of threats to the Great Barrier Reef is not only all these constituent problems, but the cumulative impacts of these things together.
So John, just on that, whilst it's cumulative, are there certain ones that, you know, the real game changers that we should be most concerned about and prioritising?
So, yeah. The temperature is a major one for the coral itself. So if we're just looking at corals, so the GBR, like I said before, the GBR comprises way more than just corals. But if we just focus on corals themselves, the marine heat waves that have occurred over the last decade or so have been responsible for significant bleaching. And so the process there is the temperature goes up, the zooxanthellae, or the algae which are within the corals, are expelled, and the corals are unable to use light as a source of energy. And those corals fairly quickly get overtaken by algae. And so you get a compositional change in the coral reef. And so marine heat waves and elevated temperatures are a really serious problem. And that's the sort of thing that has become quite evident. So yeah, to answer your question, that's one of the main ones. But then if you look at cyclones, the damage a cyclone causes is significant. Cyclone comes through, it just takes it right out. So if it goes over the top of an atoll, then it'll take some time, many years, for that atoll to come back. So what we're looking at is a huge system with lots of different impacts. And depending on what you consider to be important, and the time scale you look at, and the spatial scale you look at, whether it's a single atoll or the whole reef, really defines on what that threat is that you're interested in.
Thanks for that. It's food for thought, isn't it?
Yeah. There's a lot to this system. So the issue that's come up recently, which I imagine a number of you are aware, is that the Great Barrier Reef has been listed as a World Heritage Site. And then, and to do that, it has to meet certain criteria. And so the government document that defines the Great Barrier Reef as a World Heritage Site addresses 4 of these criteria, at least in the document I read: natural beauty, physiographic feature, so it's quite a significant feature. It has unique ecological and biological processes, and within Great Barrier Reef there is considerable biological diversity. And so a nice document was prepared and submitted to the World Heritage, listing people within UNESCO to list the Great Barrier Reef on the basis of those criteria. Now, the GBR significantly suffered from mass coral bleaching events in those years, 2016, 17 and 20. And I think after 20, I think it's even been, someone in the audience may be able to say, but it may even been 21 where there was also some serious heat. What has happened from the observations of the reef over the last 5 or 6 years, actually before then, because it was 2017 when that listing was modified, was listed as in danger, and then one of our ministers had that delayed to February this year. And I think it was the 2nd of February this year, a document was listed to UNESCO describing how the reef should not be listed as in danger. So the issue there was that the water quality was declining in the reef. UNESCO saw those reports, concluded that the reef is under threat, said to the Australian government, well, look, we're going to put it as in danger. And the government's going, oh, no, we don't want that. And so they put together a case to delay that. And then in February this year, they put together a more cogent case to prevent that from occurring in July. And so part of their response, the government's response to UNESCO, was that they're going to invest a lot of money. So the total investment in the reef, more than $4 billion to 2030. That's assuming they remain in government till 2030, but won't worry about that too much. They said that they'd allocate efforts to rehabilitate and restore key habitats to support threatened species. Very good. And the reef's ability to adapt to climate change is fundamentally tied to the success of efforts to reduce stresses. So the government's going to reduce stresses from elsewhere. So their $1 billion reef protection package includes these 4 components: actions to improve water quality, $500 million, support for world-leading reef management, reef restoration, adaptation, strengthening partnerships and stewardship. So they've jumped around and they've made quite a big effort to allocate funds to things which are important, and that's a great thing. So Australia shares a target of net zero emissions by 2050, and so the Australian government has a position on global climate change where they say that, and that's good because climate change is the elephant in the room about damage to the reef. An updated long-term sustainability plan, that's great. Met or exceeded our water quality targets and increased total investment. And so there's a bunch of things our government said that they're either doing or they will do, and they're allocating funds to that will improve the status of the reef. And that's great. What will make a difference? Well, clearly reduce sedimentation, reduce nutrient loading and reduce pesticides. That'll make a difference. And a lot of that is happening. A lot of that has to happen on the land in the catchment. So sedimentation is strongly tied to cattle and cattle wandering around and causing a lot of creek damage. Nutrients from things like sugarcane, for example, where they're using fertilizers, and pesticides just being used generally. So reduction in those things can happen by education and providing options to farmers. A lot of farmers are across this. They want to help, but they just need to be given the tools to do it. In terms of marine debris, personal care products, anti-foulant, it's a matter of well, people who put these things out in the water lifting their game. But it's also about government introducing legislation to reduce those sorts of impacts, to reduce those sorts of things getting into the reef itself. But what will make a difference in regard to all those things is the cumulative and aggregated impacts. So it's not just the sedimentation, and it's not just the nutrients, and it's not just the pesticides. There's all these things together, and that's what we need to address. Is what are the cumulative impacts, and how can we stop all these things happening? So, as I mentioned, the elephant in the room is climate change impacts. And so ideally what we'd have is we'd reduce the rate at which the climate's changing in the planet, so that we'd have fewer and weaker cyclones, and we'd have less flooding. That would be helpful. Reefs would actually appreciate that, and they wouldn't get as damaged so quickly. Milder and shorter marine heat waves, that'd be nice too. If we reduce the rates of ocean acidification, that would also be good. So it's a bit tongue-in-cheek, because these sorts of impacts are significant, but the effects are due to actions which occur not only in the catchments of the Great Barrier Reef, but around the whole planet. And as I said up the top part of this slide, to reduce the cumulative and aggregated impacts of all those inputs needs to be considered along with the climate change impacts, which are also causing additional stress to coral reef communities. So go to the next slide, please. So Gobrumpa, the Great Barrier Reef Marine Park Authority, has been undertaking marine monitoring for quite some time. I'll just jump through this fairly quickly. They've basically been looking at the things that I've discussed, the things that need to be looked at. So they look at corals, distribution and abundance. Are the corals declining? How are they changing? Same with seagrasses. So there's a regular monitoring program that addresses these things, and it's been going on for quite a few years. Water quality, they measure as well, total suspended solids, turbidity, Secchi depth, which is a measure of light, chlorophyll A, how much chlorophyll A there is. They use that as a proxy for phytoplankton abundance and nutrients to some extent, and then nutrients themselves, pesticides, so, and temperature and salinity. So there's a whole bunch of water quality measurements being done, which is great. It's what we need. Next slide. And here we have some images from one of the reports. On the left is sediment particulates, and you can see the Burdekin catchment has a very high contribution of sediment and particulate nutrients compared to the other catchments. But the dissolved inorganic nitrogen has far less area, which is contributing to that. It's not such a big problem. And pesticides is clearly not even a problem at all up in the far north, as you'd expect, because there's no one up there much. So work's being done, information's being gathered, and then management actions can be taken. In terms of water quality monitoring, there's a whole bunch of techniques that are being undertaken, and these are the things we can use: manual sample collections, autonomous samplers, data loggers such as the one in the image, remote sensing, weather stations. There's a ship now doing ocean acidification work up and down the reef. There's use of bioindicators, which I've had a fair bit of experience with. And then we've got the Australian water quality guidelines we can use as a comparison. So there's a fair bit of work being done. And
do you think, John, like there's obviously a lot going on there, but given we've got so many lines of evidence, why do you think we get such contradictory messages coming out from people talking about the health of the reef? Like, surely the good old scientists can give us a quantitative answer to this.
Well, if you look at how big it is and how much the area is actually encompassed by the reef itself, and you can visualize the small places where people go and take their measurements. We have what we consider to be a representative understanding of what's happening to the reef. There's a hell of a lot that we don't look at. And it's very easy for some people to cherry pick. They cherry pick the reefs that look really bad, and they say, oh, look, this is really bad. Or on the other side of the coin, people cherry pick all the good looking reefs, and they say, look, the reef is unaffected. And so there's enough evidence there to look at both these things.
Do you think, like a lot of monitoring programs, the challenge is scaling, right? So you're saying, okay, we've got representative sites, so someone's made the call on that we've got enough of those. But often when we're trying to join the dots between these sites, we might use them as ground truthing and then use something like satellite imagery and interpretation of that. Is there a lot of that going on? Like, how are we going to get to something more meaningful as an indicator at scale?
Well, the satellite imagery is a really important part of that. Glad you mentioned that. That's being undertaken. There's a lot of attention going into satellite monitoring from what I've read. And that'll give us a pretty good overall understanding. But yeah, it will certainly need to be ground truthed. I think the statement you made before that presumably we've got a good representative bunch of sampling sites. I always worry about that because it is so big. The reef is such a huge place, and we're constrained. We don't have enough funds to necessarily measure all the places that we perhaps should. So although we have a pretty big monitoring program on the reef, not only Gabroompa, but all the universities and other organisations, is it enough? I don't know the answer to that. And that's one of the questions that I'd like to throw up in the air, and people can look at that. Is it representative? Are we really getting a good understanding of how the reef in all its little different atolls is actually responding?
I suppose another question is 4 billion enough, right, John? Right, seems like quite a bit of money. You know, how much is needed to really assess the health of the barrier reef?
I strongly believe that the questions are the most important thing, and then the money flows from those questions. And my concern is, are we asking the right questions? As soon as we ask the right questions and start getting that data, then we work out how much cash we need for it. I mean, government loves to throw money at something and say, oh, look, we're good, we're looking after this because we're putting money down there. But a little bit cynical about that. I mean, the good side of it is that there's a lot of monitoring being done, and there's a lot of assessments that being done. There's a lot of good science being done on the Great Barrier Reef. What does concern me is that a lot of money is also being spent. Is that money being wisely spent? There is a committee in the foundation that assesses a lot of those federal funds, and there's a bunch of experts who comprise that committee. And I have faith in a number of those people who I know of and know. So that's a good thing. But we always need to continue to be vigilant about, spending billions of dollars on something just so it looks good. We actually want to spend those billions doing something useful. And not to say that it's not being done usefully, but it's something that we should always be aware of, I think.
You mentioned earlier about the farmers, and that sugarcane growers and that sort of thing are aware of the impacts, and they have goodwill towards protecting the reef. In terms of changing management practices to facilitate change, whether it's reducing impacts on groundwater, but discharge or that sort of thing, all very doable from a management point of view. Do you think there's enough money going into those areas, or do you think it's sort of being diverted to things that perhaps are less important?
When it comes down to it, it's the individual farmers to make the call as to whether they spend the money they have to, for example, prevent or reduce the amount of sedimentation going into the river, perhaps through the use of their cattle, for example. So it's their call whether they put fences up around the creek or not. Now, there may be some legislative requirements that they need to comply with, but it comes down to, a lot of it comes down to individuals. And I mean, if they're given incentives, perhaps more carrots and sticks, then some of those billions of dollars could actually go into assisting local farmers to do those sorts of things. I mean, I'm not in a position to say what's going to work and what's not, and what's the best use of money. But I do have a feeling that the individuals are out there, they want to do the right thing, but they're constrained by money. They just don't have the resources to do everything they'd like to do. And so it's always a compromise, and it's always a stress. There's always that strain between doing the right thing or making a dollar and not going out of business. Yeah.
A tricky balance for all of us, John.
That's exactly right, yeah.
Next slide, perhaps.
So here's a bit of context, this one. Yeah, so the corals. I was just looking up corals over the last several 100 million years. And apparently corals have disappeared from the fossil record quite a few times, and they've come back. So that's interesting. We don't know whether they'd ever come back if they died all completely now. We don't know that. So let's not just assume they'll all come back if they all died. So until around 20,000 years ago, the sea level was a long way down because the Earth's temperature was down. And there's a lot of ice. A lot of the water in the oceans was locked up as ice around the poles. And then after 20,000 years, everything started to warm up. But that far ago, a lot of the islands in the GBR were exposed. So the corals that were there weren't alive at all. And now the current GBR stabilised around 6,000 years ago when the sea level reached an equilibrium point. And so as the sea level changes, the species composition changes. And depending on the rate at which the sea level goes up and the rate at which the corals can actually go upwards, that affects the types of corals that predominate. And so if the sea level is going up at a very fast rate and the corals are not keeping up, then the corals will end up being in deeper and deeper water. And I think that was actually inferred from some of the studies that people have done, that some of the larger, rounder corals are better able to cope with low light, and they were predominant for a period of time until the reefs could actually get to the surface.
John, you say if the rate goes up too fast, right? We know a fair bit about these now, don't we? So based on the projections of sea level rise that being bandied around associated with climate change, etc., is it going to go up too fast, or do you think that the reef will keep up okay?
I think the reef will keep up. It'll keep up with what's happening at the moment.
So sea level rise isn't too much of a headache for the Great Barrier Reef?
Not the current projections, because the current projections are that it's actually going to back off. Temperature's going to rise up to perhaps 2 degrees. I mean, some of the projections go to 4 degrees or whatever you want to look at, but it's not my area of expertise. And so, someone in the audience might actually have a better knowledge about this than I. But the impression I've had from reading is that the coral reefs that we've got now are not under threat from that. In fact, if the sea level is going up a bit faster than they'd like, it might be better for them because they'll be less affected by elevated temperature at the same time as lots of light. So one of the things that corals don't like is they don't like lots and lots of light. So in the middle of the day when the sunlight's really bright, the zooxanthellae, the corals, undergo what's called photoinhibition. And they reduce in their photosynthetic capacity, and they adapt, or they acclimate to that high light. So if we've got a combination of very high light in a very shallow water, and we've got those two things going on, that's going to cause a lot of stress to corals. If they're actually a little bit deeper, it's going to be better for them. They won't get quite so much light. There you go, 4 millimeters per year at present. So I think about 5, thanks David. So I think about 5 millimeters was the number that they were talking about in the study that I read. And so it's around the same rate. And the coral survived. So, yeah.
So from a sort of management perspective, it's always nice to, I deal more with industrial facilities, right? But, in terms of having some rule of thumb indicators of is the reef going to be okay, I sort of feel that it would be nice to have some indicators that, you know, we could all put our hands on our heart in Australia and say this is sort of where the reef would be okay, and based on modelling and projections, if we stay within these bounds, even the cumulative bounds of whatever, it's sort of like a management plan based on monitoring metrics would be nice. So just the last one before I let you proceed. So I always think about ocean acidification. That's something that really can't be disputed. You know, you've got emissions occurring and you've got equilibrium leading to acidification. So it's happening, and it sort of seems to be related to hydrocarbons being burnt up in engines and stuff. So what's the level of knowledge around the impact of acidification on the coral health?
So a fair bit, as you'd expect, a fair bit's been done in ocean acidification in marine systems. One of the main things is to do with calcification rates. So there's been studies looked at things called pteropods, which are little organisms which have calcareous bits within them, and their capacity to produce their calcareous structures has been severely impaired by the changing pH. And so with corals, the story, the general story in terms of the ocean acidification of coral is that with a increased acidification, the processes within the organism to accrete coral are energetically stressed. They require more energy to do the same thing. So yes, they can continue to create those calcareous structures, but it takes more energy to do that. Now, this is an interesting thing. You can look at that and say, well, okay, is that a good or a bad thing? Now, going back to that scenario where I was talking about very shallow corals getting lots of light. So one of the things with photosynthetic organisms is that if you give them lots of light, they need to do something with it. Now, if you've got a coral which is energetically stressed, it needs more energy to actually do the calcification. Is it true that that coral might actually be able to use that extra sunlight to do the calcification, use that as a sink? And so that way of looking at things is not often progressed. And so there's an example where a friend was, he was growing microalgae, and he grew microalgae with nitrate and with, I think with nitrate and without nitrate. So nitrate takes up, what was the story? The story was essentially that organisms used light energy to do physiological functions that required energy. And in doing that, they were less susceptible to photoinhibition. And so corals could be in that situation. And I don't know, maybe there's literature, maybe people have actually done work on that. But ocean acidification could actually create a benefit, but it can also create a serious problem. So the system is not simple.
Is that one of the problems, John? It's not as simple as we think, right? So
that's the nature of today's discussion, really. From my point of view, the system is not simple, and we've got a lot of vested interest in making very bold, simple statements. But as scientists, we need to recognise that it's not a simple system, and that to spend our hard-earned taxpayers' money on something which we all value, I think we need to dig a little deeper and to get a good understanding of what's going on. So yeah, it's not a simple system at all.
The trouble with scientists is they're always worried about the unknowns, you see, John, whereas people managing the place need some certainty to invest, right? So is there a way to, you know, get the scientists to get more towards pragmatic management guidance that's going to be helpful for the government? Like, it's easy for us to point fingers at the government and say, oh, they're spending it in the wrong place. But if we can't give them guidance on where to spend it, it's a bit hypocritical, right? No, I just think, what are your thoughts on that slightly contentious point?
we need to definitely provide government with the guidance that they need so that they can spend the funds wisely. I mean, absolutely. I think as scientists, we need to keep those open minds and to see as widely as we can and to look at all the sides of the coin. I mean, there's clearly some problems going on, serious problems. The bleaching events, there's a lot of corals which have been bleached, and that's not a good thing because they get overtaken by algae and it takes ages for them to recover, if they recover at all. There's clear problems, but it's the mechanisms and the solutions which I think we need to focus on and keep government informed of these things. I know it's a fairly blanket statement, but I suppose what I'm trying to say is here's a situation that we're being told by the media and government it's a simple problem. And I'm saying it's not a simple problem. And it's actually a sign of the times that we've got an environmental issue and we've got people trying to simplify it to the point that we can't help. We can't make decisions on a simple premise. We need to know what's going on. And there's a lot of good people doing that work. So we need to get that across to government in a way that they can make decisions.
Do you think there's been anything wrong with the government saying, we're not quite sure? Like, do you think it's just sort of an integrity piece where, you say, look, we're gathering all this evidence. We're not quite sure on this. We have some certainty on certain things like reducing sediment so we can focus on catchment management at this stage, but be aware there are unknowns and nothing certain. I don't know. It's just
look, I think it's a personal thing, personal opinion. In my personal opinion, that's a very brave thing to say, and I think it's worth saying that you don't know. I think perhaps more usefully is to provide some level of uncertainty. And that's what you mentioned there, is to say, look, we've got an idea that this is the case, but we're certain to this amount, to this degree that this is going on. IPCC report provides these levels of certainty, and they couch it in English, but there are numbers behind it. So we're I can't remember the terms, but we're moderately certain. We're very certain. We're really very certain. It goes up to the scale of saying it's almost 100% certain. And so if government's going to provide comments like, oh, we don't know, and if they can provide some level of certainty or uncertainty, that is a helpful thing. But ultimately, they should say that they don't know. I mean, there's a lot of things we don't know, and government can't know it if we don't know it.
It's not really setting a precedent to do that, right? So there's always, around government expenditure, like I remember Snowy Mountains, when they were trying to work out what level of risk they were willing to take on future landslides, and they did a whole lot of sort of quantitative risk assessment on likelihood of there being another landslide, depending on how much engineering works they put in. It's the same philosophy, isn't it? If we spend X amount here, we've got X level of certainty of, no future bleaching, that sort of thing. I'm probably rabbiting on a little bit, but just thought I'd make that point. Better go to the next slide, I think, John.
Okay. Here we go. So here's some results, which is great. So you've got the reef on the left, and you've got 3 rows: the northern Great Barrier Reef on the top row, the central on the middle row, southern on the bottom row. And on the left, we've got the number of reefs surveyed. So it's 54 reefs surveyed, hard coral reef cover per reef. That was 54 surveyed up the top. In the central reef, 53, and only 20 in the south. So if you look at the cover, hard coral cover, which is the second column, it's gone up in all of those parts of the reef. And crown of thorns has either stayed the same up north. It doesn't outbreak in the north, it outbreaks somewhere in the sort of the upper central part. The COTS actually outbreaks and it goes south. So there's no outbreaks in the north. And then left outbreaks in the middle and the south, which is great. And then the severity of the bleaching appears to have gone, it's gone down in all levels. So that's actually a great report card. And that's the sort of thing that our government is surely wanting to put into the submissions to to UNESCO. And actually, that's great. I mean, I'm not being cynical. It's a good sign that things are actually looking good.
So, John, that's a pretty positive report card. You know, from a scientific integrity point of view, can we all trust that and say, okay, things are improving?
Well, in regard to those things, yeah, sure. I mean, it's whether those hard coral cover, crown of thorn starfish, and bleaching severity, and hard coral cover per reef, whether those attributes are sufficient for us to actually definitively state that the reef is in good health. Now, I would argue that there's a lot more to it than that. I would argue at a certain level that's great, and actually that does tie directly into the charismatic observable coral reefs that people dive on and snorkel on and love. But the reef system itself is way more than just those little coral reef atolls that we love to dive on. It's, like I said before, it's a huge environment going down to 2,000 meters. You've got all those lagoonal spaces between the islands. So what's the effect of those lagoonal spaces? We've only just started to do studies down at those depths. 90 meters. It's not incredibly deep. Too deep to dive for any length of time, but it's not too deep for ROVs. A bit shallow for submarines, but there's a whole stack of parts of that reef which we haven't looked at and we haven't measured and are not on that list. That list is primarily for the public who will understand that sort of stuff. But I think as scientists, we need to actually look a little bit deeper than that. Yeah. So it's a good report card, but I think it's not the whole picture. Yeah.
So in terms of hard coral cover, is that calculated based on direct observations of those sites, and then is it extrapolated through that satellite imagery? Is that how that's done? Or
I think those little cells, little squares there, the red, orange, yellow, and green, they represent each individual site. Now, I don't recall, but a site may be an atoll, or maybe a number of sites on an atoll. So you can, you can see that the proportion of red to the other colours is, well, you're looking at the upper and the middle, the northern and the central ones. They look fairly similar. And then the southern one, there's only one cell, one reef, which was in the red. So, yeah, you can get some information out of that.
So as with all environmental monitoring, it is more about the trends than the absolutes. So you'd have to say it's looking good, right? We don't hear maybe enough about that there are some positives. I think people are putting a hell of a lot of effort in. It's good to recognise that, I always think that monitoring linked to activity is very meaningful, right? So people then feel happy to invest more. It would be great if we could put our hands on our heart and say, look, this is working and it's linked to catchment management upstream. And I'm sure there's some work that's been done on that. But we should be talking to that more, I think, right? We should have a meaningful other part to this, which talks about, okay, these are the management actions, this is the change in catchments that we've made or whatever, and quantify that somehow, versus these are the indicators of how it's going.
Yeah, and I think some of these indicators here, in terms of like the status and trend, give us that temporal change, and we can link that up with some of the management actions which have occurred. But unfortunately, it's a little bit confounded by things like cyclones and flood events. And so to tease apart those management actions and funding initiatives which have changed impacts on the reef, to separate them out from the natural occurrences of floods, cyclones and things, and other climate change effects, that's a bit tricky. But that would be certainly a good thing for the researchers in this field to do. that'd provide a bit more certainty.
I'm a little bit worried about time. I'll let us shoot on to the next slide, and then I think that's the last slide, the next slide. Then we better get some of these questions answered that are coming in. But here we go. Oh, it's back to me. So takeaways from today: multiple threats to the Great Barrier Reef. We've heard of those from John: fishing and commercial activities, crown of thorns starfish, water quality, cyclones, marine heat waves, ocean acidification, and then really the cumulative impacts of the above and how one really can create a meaningful indicator based on those cumulative effects. I would have thought requires a fair bit of careful modelling.
Yeah.
The other thing is the government is investing a lot of money here, right? I think that's something, you know, regardless of why, they are investing a lot of money. And I suppose on reflection, UNESCO, you know, really got things happening, right? That threat to that categorisation has led to, you know, some really positive outcomes. So sometimes we get a bit patriotic and say, what the hell does an international organisation have to do with Australia? Well, in this instance, the process seems to have worked. But without further ado, I noticed that most people didn't follow my instruction of putting it in the Q&A. It's almost a psychological thing. But I'll start with the Q&As and reward them. So, comment from David Detrick. I just did some regression on number of cyclones in Australia from 1970 to 2018, and it is clearly trending down strongly. Are there any comments on this issue?
Wow, that's interesting. That's very interesting. So that's yeah, that's cyclones that are actually impacting on the continent or the reef, I'm assuming, David.
I don't think David can answer.
No. Look, that's a really interesting comment, and that's the sort of perspective we need in these sorts of discussions. At a national level, people make decisions, government makes decisions, and it always worries me whether they're making all cyclones across Australia. Thanks, David. It always worries me whether they're actually looking at the sorts of data that you just looked at then, David. And it, you know, doing that regression didn't take you forever to do, but you found something which is quite significant. So, yeah, good point.
Next, David, we've already covered the 4 millimetres per year sea level rise. So, Nicholas Carvello, is there the potential for local industries to have a significant positive impact on the reef? Regenerative ocean farming of seaweed, for example, reducing elevated nutrients.
Yep. Whatever people do in the reef, they can do it better if they're not doing it better already. In terms of algal functions, they'll actually take up nutrients, as you're probably aware. So, you know, I imagine that's the subtext there. Growing macroalgae in the reef will take up inorganic nutrients, and depending on the species, they'll take it up really quickly. So, yeah, it's a good option, and there's actually a market for it. So, you know, growing macroalgae in Australia it's never been seen as a good cash crop, but I think that perception is changing slowly.
Is it lucrative overseas?
No, it's not lucrative, but it's a good solid cash crop for some people. Yeah.
Okay, now over to Q&A, which continues, the chat, which continues to grow strongly. So yes, that David's comment was based on all. I'll go back to the beginning.
Yeah. David's comment in regard to the cyclones occurring, what was it, less frequently, but more severely. One of the Bureau of Meteorology's comments about the weather is that there's more variability in some parts of the continent than there was before. And I think we're beginning to see a little bit of that, although it's very hard to be objective. And so, yeah, so the climate's changing, but not necessarily in lots more cyclones, but fewer, but bigger. And here we're getting, we've got a thunderstorm right now, so hopefully it won't get cut off. We've got rain in big, short, intense bursts of rain. And they're nothing, rather than before where we didn't get that sort of event. So the climate is changing in that sense.
Okay, next comment, this one from Jenny Stauber. Just to note that the Office of the Great Barrier Reef Environmental Policy and Programs, Queensland Department of Environment and Science, also has a large management role for the reef. Thanks for that, Jenny.
Great, thanks, Jenny.
And we've got some from David that I think we've covered. CSIRO predicts increased rainfall intensity and I guess the question is, and more erosion. Have you seen much around in terms of projections of what that impact could be on the reef?
No, I haven't seen any projections on the reef, but I have seen corroborating reports from the Bureau of that sort of event happening. So more intense, maybe shorter, but just more intense events. And you could expect that would create more erosion in some parts of the landscape. So yeah, there's a potential issue there with increased sedimentation and yeah, subsequent damage from that.
We're doing a fair bit of work at the moment on catchment rehydration and riparian zone revegetation. You know, I think sometimes it would be good if we could look at both at once, right? So what would be the potential if we did restore all riparian zones, for example, in terms of impacts on the barrier reef? It might change where the money's spent, right, to something which is a good management outcome. It's just pondering, really.
Well, the land management's a critical part of this reef management, overall reef management issue. And I think there's a fair proportion of people who are aware of that, but perhaps the general public's not quite aware of the link between land management and the reef itself.
I've had another one pop up. Apologies for not staying in sequence on the chat, but it's punishment for not putting it in the Q&A. So this one's from Luke Peel at the Malone Institute. Good Lord, it's jumping around to me. Really, the essence of it is how important are the mangroves as a nursery, but also a filter and buffer zone for storm surge and trapping of sediment?
Well, they're important for those things. They're also important as a habitat for juvenile organisms, including fish. So the mangroves are very important. So yes, they slow down the sediment and they trap it, but they also have that they have that ability to act as a habitat, and also they act as a storm surge buffer. So they prevent large waves coming in and doing damage, which is not always the case in the reef itself, but up in the Gulf of Carpentaria, for example, where you don't have that fringing reef, the mangroves are really important. So mangroves themselves are actually a very important ecosystem or a subsystem within a larger system. And to say that they're not sexy, well, but mud's not very sexy either, but there's a lot of stuff going on in mud. Yeah.
So just press back on our beloved mangroves, right? How easy is it to rehabilitate mangroves, i.e. plant them and get them to grow as a new zone, right?
It's a good question. I'm not familiar with any research done on mangroves in that sense. I do know that people cut them down around here in New South Wales, and they get fined heavily, but they'll cut them down because it ruins their nice view. It takes them a long time to come back. On the flip side, we've got a part of the Brisbane waters where I live, in Central Coast New South Wales, and where the mangroves they've come up in the last 10 years or so, they've come up about 2 metres. And to me, that seems pretty quick. So they do come back. It all depends on your timescale.
So they're quite resilient by the sounds of things.
They are, if you give them a chance. Yeah.
Oh, David Detrick, mangroves can be rehabilitated. Okay, needs a great deal of money. Okay.
Yeah.
Well,
I've tried growing them at home, but I've had no luck at all. I've got a friend in the United States who has them in his house, and he's grown them very well, just like a normal plant. Yeah, hand planting.
Okay.
Yep.
Q&A. Good to see some questions on the Q&A. So Bruna from Hydroterra, what are the consequences if UNESCO proceeds with the downgrading of the Great Barrier Reef?
Well, one of the consequences is that an interpretation can be made that the downgradings is a response to climate change effects. So one of the big ticket items is the heat waves. And so if UNESCO says, well, we're going to downgrade it, then the implication there is that we're not doing enough for climate change, because the heat waves are a response to climate change, purportedly. And so the climate change lobby suddenly has a big lever they can use to affect government. And at this time, when the government's coming up to an election, the last thing they want is someone else to have a lever to leave them out of their little winkled spot. So I think that's some of the political subtext. I mean, that's my opinion. I don't know that, but yeah.
So I suppose what you're saying is the greatest impact at the moment is a positive one, right? UNESCO threat to downgrade has led to a lot of positive action, right?
Yes,
So,
yes,
which
it's very good.
Ultimately, it looks like the system's working, right?
Yeah.
Andrew Wallen, what portion of the reef has been found to have pesticide residues present? What is the role of massive ocean tidal flows in dilution of nutrient/pesticide impacts?
So if we go back to the slide that has those 3 images of the reef, can you flick back to them, Richard?
I'm going to try. It's I've got to overcome a bit of IT here. I might have, oh my goodness, what happened then? There we go.
There, that one, yeah. So what have we got? Pesticides on the right, and that will give you an idea. So you can see that the red, where's the red? That looks like it's just south of, is that Hinchinbrook there near the M? I don't know. But yeah, that area where the red is, that's clearly got a lot of pesticides. Now, in terms of flushing, if you look at the reef image on that diagram there, on that figure, there's a whole bunch of islands offshore from that spot. The issue with the Great Barrier Reef is it sits within the Great Barrier Reef Lagoon. And so oceanic flushing is largely constrained by all those offshore islands. So yes, there is some flushing going on, but it's not the same as you'd get if the reef itself wasn't there, if those offshore islands weren't there. So the pesticides are a problem. Some of them break down, some of them don't. Sediments are a serious problem. Yeah. And some of it gets flushed away, some of it doesn't. So there's a bit of perspective there. Yeah.
Okay, thanks for that. So Dan Evans. Hi, John. Thanks for the fantastic talk. The Queensland Modelling Network are currently producing a nutrient trading gamification project.
Wow.
This will scenario test multiple management approaches, including up-gradient catchment mitigation in terms of both costs and nutrient load treatment efficacy for down gradient receiving waters. You can obtain more information from, I hope I get the pronunciation right here, Abel Imiraj, if interested. and his email address is abel.imiraj@oricongroup.com. Well, that certainly sounds like it addresses one of my earlier comments, which was it would be great to be able to have a sort of quantitative link between management practices and observations. So that's pretty exciting. I think one of these things is there's a hell of a lot of good work going on, but not many forums to actually really talk about it in a clear way. So we end up with a lot of sort of media grabs and that sort of thing instead of, you know, except for the odd conference. But I think a lot of people care about the reef, and we do need forums that can provide them with integrity in terms of what's going on. Just a couple of comments that have come in, and then we probably should wind it up. It has been fantastic, by the way, John. I think you've done a really, really good job. David Detrick says, CSIRO predicts increased rainfall intensity and more erosion. I think we covered that one already. So, and then the next one, what are the limits on Queensland clearing rates, if any? It's probably a bit rough. John is a marine person, but...
I'm sorry, that was about clearing rates?
Yeah, what are the limits on Queensland clearing rates, if any?
I'm not sure. My devices are going off here, sorry.
We might take that one on notice. But let's call it a day there. Thank you very much, everyone who's participated in the webinar today. I think John has done a great job of sort of bringing us up to speed on some of the issues around the Barrier Reef and some of the great work that's going on. I think my take home from this is there is a lot going on. It would be great if we could hear about it more often in a more open forum than we get in the sort of current media flows on this. So many thanks to everyone, and congratulations, John, on a really good webinar. Thanks very much.
Thank you all.